Hello and welcome to today's class. For today, we'll be discussing an important aspect under integration called definite integral. So, what's definite integral? By definition, definite integral are integral in the form a b f of x dx. So definite integral are simply integral in this form, right? Where a and b are called limit, please. Where a and b are called limit, right? So it means that a is called upper limit, while b is called lower limit. That's the concept, please. So also note that we said a is what the upper limit, right? We said b is called lower limit. So hence a must be what? Greater than what the b. So for most cases under definite integral, the value for a is always what the bigger than what? Than b. So in most cases a is always what? Greater than what the than b. So when it comes to definite integral, what's the mathematical representation of a definite integral? The mathematical representation of this man here, if I have the integral of a upper limit a and lower limit b of a function of x dx, what is the mathematical representation of this? It means that I'll have the integral of f of x, right? F of x dx, right? With a here minus into the integral of that same f of x dx to power what there? To power b. So it means that the mathematical representation of the integral of upper limit and lower limit of a function of x is simply pick out the integral and the function of x. As in this case, the upper limit goes with this one, the same thing here, and the lower limit goes with this one. So this is like the mathematical representation of a definite integral. So let's take a sample problem or perhaps an example under this to further explain this concept, right? So let's say I have an example, evaluate the integral of 5 and 2 as upper limit and lower limit of 3x squared dx. So I'm told to solve this man here. Of course, without stress, this is a definite integral question. Why? Because I'm having what the upper limit and what lower limit. Observe something again. We said that the upper limit is always bigger than what the lower limit, which is true here. Now in this case, how do you solve this? Look up, how do you solve this? My first task is that I will ignore the limits first. If I ignore limits, I'll be having what the integral of what? 3x squared dx. True or false? True, right? So now look up. I'm going to solve this one here using the idea of general method of integration. So if you are not familiar with the general method of integration, kindly check the description of this video. I'll drop a link that will teach or perhaps explain the concept of general method of integration. So for this case here, what do you do here? I'll take out the constant term outside the integral sign. 3 outside the integral sign. I'll have that 3 integral what there? Sorry. I'll have 3 integral what there? X squared dx, right? So it means that I'll have 3 abi. If I integrate x squared, I'll have what? X power 2 plus 1, add 1 to the power. All over what I'm having here? 2 plus 1. I've integrated x to power x squared. Next up, plus c, right? Plus c. If you're familiar with general method of integration, you should know this. Alright, from here now, I'll have the answer to this one here becomes 3x to power 3 over what there? Over 3 plus c. True or false? Of course, 3 cancel 3 here. I have x to power 3 plus c, right? As my answer after solving this one, Abby. Now it means that if I want to introduce my limit, Yeah, we said look up. We said pick out the answer like this. Yeah, the first limit comes here, Abby. That same thing here. The second limit come here, Abby, and I have a negative in the middle. So it means that from here now I'll have a square bracket s cube plus c, right? What's the first limit? 5, Abby. So I have 5, right? Okay, 5 and what? And 2. True of us. So my limits are what? 5 and 2. So let me express one mathematically in this form. So I'll have what? S cube plus c out by what there? 5 minus what? The same thing. S cube plus c out by what there? 2 in this case. The same thing, please. So I'm here. So from here now, what do you expect from here? It means that anywhere I see x, I'll put 5. Anywhere I see x, I'll put 2. That's the meaning, please. So it means that anywhere I see x here, I'll put 5 there. So I'll have what? 5 cube, true of us. So plus what there? Plus c. I'm having a minus sign here into 2 cube plus c. I'm here. So it means that what's 5 cube, please? 125 plus c minus, I have what there? 8 plus c. Expand this bracket using what? Minus. I'll have that 125 plus c minus times a is what? Minus 8 minus times plus c is what? Minus c. Of course, plus c cancel what? Minus c. And if it's what? 125 minus 8. Please give an answer, please. One answer, please. 1 there? 117, Abby. Please confirm this answer, please. What, Abby? Now look up, please. I want to know two things, please. Not two things, please. Look up. For definite integral alone, your answer is always what? A value, a whole number, right? That's number one. That after solving your definite integral question, you have what? A whole number as value, right? Next up, look up. Next up, observe that plus c here is what? Cancelling that, Abby. At the end, I'm not having plus c here. So plus c is what? Optional. So normally, if I integrate something of this nature now, I must add plus c to my answer normally. But for definite integral, plus c is what? Optional. I can choose to what? Take plus c. So look up now. If I don't want to use plus c now, look up. If I don't want to use plus c in this case, you know I'm having plus c here. Plus c, Abby. If I don't want to use plus c, I'll have what? X to power 3, Abby. X to power 3 as my answer. So if I want to express x to power 3, what's my upper limit? 5 and what? And 2. True of us. That becomes x to power 3, then my 5 here, minus what there? X to power 3, next up 2. True of us. I'll have, anywhere I see x, I'll put what there? 5. That becomes 5 cube, minus what there? 2 cube. That's what? 125 minus what there? 8, which will give 117. The same thing, please. So putting c is what? Optional when it comes to definite integral. Example 2, please. All right, let's solve this example 2 using the idea of definite integral. So what's the first task here? We said to solve a problem on definite integral. Note number 1 is that the upper limit is only what there? Greater than what the lower limit. True or false here? True here. It's also the second thing to note that we said to solve a problem under definite integral, ignore what the limit first. So pick out your integral symbol. I will ignore limit first. Pick out the integral symbol. The integral of what the x sine x plus what the exponential x. Next up, the x. My first task say if I apply my general method of integration, I will expand this bracket, right? So that becomes integral times sine x becomes integral sine x. Attach this one to it, the x. Next up, I'm seeing a plus sign, plus integral times exponential x what? Integral of exponential x. Next up, the x. True or false? True here. Look up now. From here, if I integrate sine x, hold on, please. Huh? All right. From here, look up, please. From here, if I integrate sine x with respect to x, all I have there, I'll have what there? Minus cos x. Look up, please. For differentiation, it's quite simple. If I have sine x, what's my answer there? I'll have cos x for differentiation. If I I have cos x, I have the minus sine x for what the differentiation. Now for integration is because of the reverse. So if I have the integral of sine x, master the what the what answer there? Minus cos x as my answer there. If I integrate cos x, all I have there, I'll have sine x. Now look up. From that idea there, from here, if I integrate sine x, I'll have there minus cos x. True or false? I'm done with this one. Plus, if I integrate exponential x, from differentiation, if I have that y is equal to exponential x, the y over the x is still what the exponential x. I have the video for this one is already in the YouTube page, so you can check for the video for this one. So if I differentiate exponential x, I have the exponential x. Similarly, if I integrate exponential x, I have the exponential x. Next up, plus c. You said plus c is what? Optional when it comes to what? Definite integral. Why? Because at the end of our solving what? It's cancelled out, Abby. So let us ignore c in this case. So my answer here becomes minus cos what then? X plus what? Exponential x in a square bracket. Now what are my limits that I ignored? I ignored what there? 1.4 and what? 0.2. Put them here. 1.4. What there? 0.2. Now apply a general formula for definite integral. That becomes what? Minus cos x plus exponential x. This man here, pick out the first limit, 1.4, minus, pick out the same thing here, that's minus cos x plus exponential x. Next up, 0.2. So anyone I see x, I put there 1.4. This means that minus cos what there 1.4 plus exponential what there 1.4. I'm done with this. Minus into minus cos what's x here? 0.2 plus exponential what there 0.2. Look up please. Help me punch cos 1.4 please. What's cos 1.4 please? Cos 1.4 please. 0.09 Abi? 0.99 Abi? Plus every punch exponential 1.4 please. Check is there. Exponential 1.4. So look up. Cos 1.4 gives what? 0.199 Abi? Plus exponential 1.4 is what? 4.006, right? I'm done with this. Minus into minus cos 0.2 is what? Cos 0. Is what there? 0.99 Abi? Yes. Plus exponential 0.2 is what there? Exponential 0.2 1.22. I'm done with this. Please help me punch. Minus 0.99 plus 4.006 please. Minus 0.99 plus 4.06 3.07 Abi? Now look up. Minus times okay, hang on. Minus into look up minus 0.99 plus 1.22 0.23. Next up, look the brackets. I'll have 3.07 minus what? 0.23. Please give an answer, please. 2.85 as my answer after 4 Abi?
Yes.
2.84 Abi?
Yes.
84. So this is my final answer here after solving this one here using the concept of definite integral.